Hello, good afternoon, everybody. I'm Dave Rubenstein, Editor-in-Chief of SD Times, and I'd like to welcome you to today's program called The Developer's Bright Hybrid Cloud-Native Polyglot Poly-Architecture Future. You can read it right on the slide because I can't say it. Okay, before we get started, I have a couple of brief housekeeping announcements. Today's program will be followed by a live Q&A, so at any time during the program, if you have a question, you can go to your control panel, click on the questions tab, type it in, submit it, and we will answer as many as time allows. Secondly, this webinar today will be available on demand on the sdtimes.com website within a day or so you can play it over and over again to your heart's content, share with your colleagues, send it to your friends. Makes a great stocking stuffer. Okay, so as we've been reporting in SD Times, the wide range of choice among development technology tools is daunting for most IT organizations. As modern application requirements become more complex, it's apparent that one runtime, one framework, or one architectural style is no longer a feasible strategy for application development. And organizations must figure out how to manage the complexity of distributed app development, diversity of technologies, lack of skilled resources, and siloed processes. So here to discuss how Red Hat approaches this problem is James Faulkner. He's a technical evangelist for Red Hat JBoss middleware, focusing on Red Hat JBoss Enterprise Application Platform. He's been a champion of open source and has grown numerous open source communities. So without any further ado, here to take it away is James Faulkner. James?
Thank you, Dave. Thanks for having me. Hello, everyone. Thanks for joining today's event. My name is James Faulkner, as Dave mentioned. I'm a Senior Technical Marketing Manager at Red Hat. And today I'd like to share with you how we are helping our customers and their developers build world-class software to compete in today's market using modern open source and cloud-native development. First of all, it's instructive to understand where we came from. So I want to take a quick look back at what's been happening in the market and where we're going as an industry on the way to the giant titled slide that you saw a moment ago, this bright future I referenced. So in the recent past, especially enterprise apps were deployed as monoliths to a centralized app server. That server provided middleware services that applications needed, like persistence and transactions, messaging, as well as operational services like centralized logging or monitoring or lifecycle management of the apps. So you had a small set of choices for these enterprise app servers like Oracle WebLogic, IBM WebSphere, Red Hat JBoss App Server, or pure servlet containers for smaller web-centric applications using Tomcat. So as far as the frameworks go, Java EE and Spring were and remain today two of the most popular enterprise apps in use today. But an interesting kind of perfect storm of technology advancements really started to take off about 3 or 4 years ago. It started over a decade ago, of course, with Salesforce and Amazon, which kind of sparked this rush to the cloud and this trend of organizations realizing that not only was it cheaper, but in many cases it was more secure and easier to manage than their homegrown solutions that they've been using. So as we move forward, we'll continue to see forecasts like this one from Citigroup that estimates around 80% of all compute will occur on some form of public cloud infrastructure by the year 2025. Obviously, this is a clear win for the cloud providers, and they've been busy taking the profits they've been making and rolling those into additional services and integrations for the apps running on their cloud infrastructure. More specifically for the developer and DevOps teams, the use of containers and immutable architectures has risen quite dramatically, again, in addition to the use of cloud over the last 3 or 4 years. So this, another example of a kind of up and to the right forecast from 451 Research, shows a very similar pattern, and I think it's in no small part due to the complementary nature of containers and cloud, which enables organizations to develop and deploy apps out to production much faster than they've been able to in the past. Part of the research here, which is not in the picture, is that of those companies surveyed that are using containers, over a third of them were already in broad implementation in production applications, and around a quarter, about 28% of them, had already begun an initial implementation headed to production. So we kind of reached that tipping point where over half the companies using containers are in or headed to production. So this kind of gold rush over the last 3 or 4 years has resulted in a number of different vendors offering essentially the shovels that companies need on their way to modern computing applications. So in this short time, the last 3 or 4 years, we've witnessed what I like to call a Cambrian explosion of platforms and frameworks for building cloud-native apps. So in that spirit, the Cloud Native Computing Foundation, or CNCF, was formed a couple of years ago to kind of help drive the development and adoption of key technologies in modern distributed systems environments. The CNCF tracks a number of different types of projects, all the way from the cloud infrastructure providers at the bottom that you can see, through provisioning and management, tooling and frameworks, and finally at the top to the development of applications themselves, where each layer sort of contains best practices and supporting software to help piece it all together. So it's kind of an eye chart, but the point here is that there's a huge number of choices out there in the market today for building cloud-native solutions. Specifically in the application server space, cloud computing and the rise of containers and microservices has resulted in functionality previously delivered by a monolithic app server to now be split into 2 or more tiers of, including an operational cloud and container platform and a separate tier of middleware services for things like messaging and transactions that were previously delivered by that monolithic app server. In addition, the notion of a single corporate app server hosting multiple apps has sort of fallen out of favor with the ease of immutable containers and microservices and lightweight developer-friendly runtimes that can run these applications. So apps today are in the process of being re-architected to take advantage of these benefits afforded by this layering approach and the separation of application versus infrastructure. In fact, this kind of new playing field of choice has emerged in parallel to, and in some sense, driven by the evolution taking place across all enterprise computing. In reality, to compete in today's environments, companies really now need to innovate through software. They can't simply buy things off the shelf. And this requires sort of a rethinking of how the software is built and delivered, and more importantly, requires a retooling of the organization to adopt more agile development processes to enable faster delivery to production across a number of different infrastructure footprints. It also requires, as I mentioned earlier, the apps need to be re-architected to be able to quickly respond to changing demand and changing requirements on developers and on the business. In other words, code sitting on a developer's desktop really brings zero business value. So this evolution taking place across process, infrastructure, and architecture are really designed to minimize that time lag, but it comes at a cost, which we're going to get into in a couple of more slides here. So customers are realizing their profits are increasingly coming from the digital side of their businesses, and it's unfortunate for them, something you simply cannot buy off the shelf. So the purchases in the next few years aren't simply drop-in replacements for existing apps. In fact, from this quote here from Gartner, they expect around 75% of all investments made by its clients in the next 2 years will be to support this digital transformation that's in progress in areas like modernizing of on-premise enterprise apps or purchasing and extending software from SaaS providers. So this trend clearly means that every business is increasingly becoming a technology business, and more importantly, software is no longer a cost center as it was in the past. It's now becoming a core asset for that competitive differentiation. So cloud native is the new foundation of these modern apps, and the statistics back that up. So here's some numbers from the 2017 Puppet Labs DevOps report, and they essentially surveyed all companies and asked them how they were developing and deploying applications. And there was a clear separation between the high-performing organizations and those that weren't as high-performing. For the high-performing organizations, they witnessed a significantly faster production deployment cycle times with cloud-native apps, less chance of failure, and a much greater ability to recover from unplanned degradation or downtime. There's always going to be bugs and unexpected things that occur when you develop with cloud-native, and some of the things we'll get into later on in the presentation, you're able to recover from those much faster and much more gracefully. So the good news is that the technologies that these companies have adopted are now also available to mainstream and traditional businesses. But let's get back to reality, right? Our customers, Red Hat customers, and I expect the industry as a whole, are spending a large percentage of their budget keeping the lights on, in this case 70% of Red Hat customers. They have existing apps that are running on today's infrastructure, realizing the business value of today, and that's kind of where they're spending most of their budget and time. They need a way to transition applications to this new world of cloud-native development without interruption and without essentially rewriting the entire business. So this might sound challenging, but in reality, a lot of our customers, and a lot of you are probably doing this today. So to address this challenge, let's talk a bit about modernization and what that means and what to do with those existing applications. You essentially have three main choices for your apps. You can rehost, reshape, or re-architect. There are other possibilities, but they're essentially do nothing. And as we mentioned before, it's kind of not really an option in today's digital economy. So rehosting, also known as lift and shift, simply moves the app as is over to a new platform with no changes to the code except possibly moving from a proprietary API to an equivalent standard API. Reshaping is very similar to a rehost, but that involves slightly more invasive approach to make the app not only work on the new platform, but also take advantage of the platform's features to provide things like better performance or manageability, or possibly add additional incremental new business value. And then finally, a re-architect is a complete rewrite using modern application development methodologies and tools like containers and microservices, which we'll get into in a moment here. So determining what to do, it's not a black and white scenario. It requires some analysis and prioritization based on business benefit and risk. For example, in the slide here, apps requiring high scale and for which you'd like to be able to sort of revise quickly to take into account new requirements or changing requirements are usually a good candidate for a reshape or re-architect effort. Larger, more established business critical apps might be rehosted first and then incrementally modernized as time and resources permit, which minimizes the risk of failure and minimizes the upfront costs and allows you to amortize that over the life of the project. So this is the reality for today and the near future. Organizations are going to continue to have a mixture of app types across a broad spectrum of technologies, as you can see in this bubble slide here, mainly because there's no one-size-fits-all base technology that works for everything. You'll have anywhere from fast-moving monoliths built on Java EE or Spring MVC on the left, over to the right with lighter cloud-native reactive apps and in the future serverless architectures, and they'll still need to talk to one another. So you'll have this mixture across your organization, and that's the reality, and that will persist for the time being. So you've probably heard this before. When all you have is a hammer, everything looks like a nail. Corporate standardization can help focus a company's technology investment and reduce the noise that developers see on a day-to-day basis, but as I mentioned earlier, it comes at a cost. The customers I talk to are absolutely aware of both the growth and advantages of modern app development, and they want to use the right tool for the right job, but they don't necessarily have time to become experts at all things. So with that in mind, earlier this year at Red Hat Summit back in June, we announced the Red Hat Openshift Application Runtimes. This is a curated and guided set of runtimes and a developer experience for organizations looking to move away from those traditional N-tier application architectures and move toward more nimble containerized microservices architectures. So the runtimes and frameworks available through the Red Hat Openshift Application Runtimes, also known as Rohr, allow you to target both those traditional monolithic Java EE applications as well as newer cloud-native apps written in a number of different languages and in the very near future, serverless architectures. This means you do not throw away your existing skill sets and the developers behind them and the time they spent learning new technologies and becoming proficient in them, but instead allows you to bring your apps forward at the speed at which you're most comfortable. So Rohr supports this broad spectrum of application types and allows you to maintain those investments in apps and frameworks you're most likely already using. So the Rohr runtimes sit just above the application infrastructure and services layer that you can see here in this product architecture diagram. Rohr provides the raw runtimes to run business logic like Vertex, MicroProfile, Node.js, and Spring. We'll get into more details on these in a moment. It also integrates with both the developer tooling that sits on the right, as well as the underlying OpenShift services underneath. So this architecture allows developers to concentrate primarily on the business logic of the application, which is really the only component that brings true business value, and not worry so much about the operational aspects of the production applications. So existing middleware services remain represented here as containerized services available through the Open Service Catalog and accessible using industry standard protocols like HTTP for RESTful services, or maybe AMQP for doing distributed messaging, essentially giving companies a choice on who wish to standardize on a few technologies and offer self-service provisioning and deployment of apps to its customers. It also allows integrations with third-party services like Amazon Web Services and others through the service catalog. So as for the runtimes themselves, Rohr is designed with the developer in mind, but also targets different usage patterns we've seen in the context of modern app dev. Existing enterprise Java EE apps can continue to provide value through JBoss EAP, which is Red Hat's modern lightweight Java EE app platform. That same EAP runtime has been optimized for both traditional bare metal or VM deployments, as well as the modern containerized cloud deployments through Openshift. For lighter weight web-centric or servlet-based apps, JBoss Web Server provides support for embedded Tomcat. As you start to look forward to Java-based microservice architectures, this is where WildFly Swarm comes into play. Swarm provides an excellent path forward, supplying just enough Java and Java EE for building Java microservices and bringing familiar APIs from the world of Java EE, along with new microservice frameworks like Netflix, Hystrix, or Ribbon, and the new MicroProfile specification championed by Red Hat, IBM, and a few other significant vendors. We'll have more detail on MicroProfile in a moment. For reactive systems and programming, those have proven their worth across a number of different industries. And so in Rohr, we have Eclipse Vertex, which provides support for these asynchronous non-blocking apps that are really critical to high-performing microservice applications. Similarly, JavaScript developers can also take advantage of the Nodejs runtime, which provides, again, a lightweight and efficient set of services for microservice developers in JavaScript on the back end, but also familiarity to front-end developers who have been doing JavaScript for a number of years, ever since the first browsers came onto play, in fact. And then lastly, Spring developers will be able to continue to use this popular Java framework and take advantage of Rohr's strong integrations with Kubernetes and OpenShift underneath. So the takeaway here is that Rohr provides developers choice, but guided choice in maintaining both existing applications and building the net new apps of the future. So to get started quickly and experience this for yourself, head over to developers.redhat.com/launch. This is an online application you can use today, and it's essentially your on-ramp to Rohr. It's designed to accelerate the learning and evaluation experience through a collection of cloud-native examples, which is what we call boosters. Each of these boosters showcases one or more aspects of cloud-native development using the Rohr runtimes, giving you both complete examples of a code base that works today, as well as descriptions of what each application does. So the application itself can be run locally, or you can run it on developers.redhat.com, and you can deploy those sample applications to either OpenShift Online or to your own OpenShift infrastructure if you want to do additional experimentation and learning on your existing IT environment. So let's take a closer look at the available Rohr runtimes. The first one I'll talk about is Eclipse Vertex. So this toolkit is geared at high-performance distributed web apps using event-driven reactive programming across the languages listed here in the slide. Vertex is really good at high-scale microservice interactions because it has a built-in distributed event bus, which aligns really nicely to API-centric microservice architectures, which are very popular and really focus developer effort on building contracts between the microservices, keeping them separated and clean. So the non-blocking execution model of Vertex allows for extremely high concurrency, similar to Node.js, but in the Vertex case, each unit of execution is called a vertical. This is a concept in the toolkit itself, and it executes each vertical in its own single-threaded event loop, very similar again to JavaScript and Node.js, but it executes it on a given CPU core. So as you add more cores, unlike Node.js, Vertex applications will automatically scale out to those additional cores without the app developer having to do anything, which is really great for developer productivity and not having to worry about running multiple copies of the same program themselves. So these non-blocking single-threaded loops that are running on these CPU cores can handle many thousands of requests, and it virtually eliminates things like deadlocks and race conditions. So this is super important for microservices who need a high concurrency, high scale performance across a number of different components in the cluster. So these microservices running with Vertex can communicate between themselves across the shared event bus, which is included in Vertex. And that event bus can span both the server nodes on the server side as well as multiple browsers. So you can kind of create some interesting interactions between things like single page apps and the backend, for example, using a very simple and abstracted message bus between them. So developers also, and myself included, also love the Fluent API, and it kind of allows you to create very concise and very readable code but it does take some getting used to if you're coming from the traditional Java programming models you might find in traditional Java EE applications. Okay, next up is WildFly Swarm. So Swarm is targeted at Java-based microservices applications as well, but you may have guessed from the name that it also brings a number of Java EE components from the WildFly ecosystem. So WildFly is the upstream open source project that JBoss EAP is based off of. It means essentially that if you're a Java EE developer, you can continue to reuse that knowledge that you've gained as you start to migrate your existing apps to microservices. We like to say that WildFly Swarm brings quote unquote just enough of the app server you've used in the past to build lightweight and efficiently packaged Java applications, which contain only the bits you need to run as an executable jar file, or what we call an Uber jar, on a container platform like Openshift. So for example, the diagram you see here in the slide shows a very small microservice that only needs support for RESTful communication using the JAX-RS standard from the Java EE world. So with WildFly Swarm, you can build a WildFly Swarm app UberJar containing only your service's business logic in the center, along with that JAX-RS component that you need, and run it using java-jar my_microservice.jar. So you essentially get a minimal execution footprint and minimal attack surface for those security-minded developers out there for your microservices. Microservice apps generally only need a small subset of functionality as compared to a traditional monolithic enterprise app. So last year, several vendors, including Red Hat, collaborated to produce a new spec that defines that subset that's extremely useful for building Java microservices. Companies really love standardization. Our customers really love standardization as well, and it gives them a choice of implementation and essentially free QA resources, because the spec is developed in the open and used across the industry, across different implementations. So the MicroProfile spec is no different. It's geared towards Java microservice applications, and there are a number of implementations available today. WildFly Swarm, which is included in Rohr, is Red Hat's implementation of this new and emerging spec. And as you can see, it includes some functions from the Java EE world like JAX-RS and CDI, but it also includes typical functions you'd find in a microservice like health checks or fault tolerance or externalized configuration support, and support for building secure microservices through the JWT or JWT token propagation. If you want to learn more about MicroProfile or get involved in the evolution of that spec, definitely want to check out microprofile.io, which is the homepage for that particular specification. Okay, next up is Spring Boot. So Spring is a really popular framework for building enterprise apps, and many of our customers are using it today. Historically, Spring was an alternative to the, at the time, the heavyweight Java EE spec, but the Spring ecosystem has really grown to include a wide array of functions outside of that spec, including Spring Boot, which gives developers an opinionated way of building Spring apps with minimal boilerplate code. So they adopt the convention over configuration paradigm and allow you to build apps very quickly without writing a ton of startup and shutdown and management glue. So Rohr includes Spring Boot, but also brings integration with Kubernetes and Openshift, and moving forward, additional integrations into the wider Red Hat stack. So for example, apps that use Spring Cloud to externalize their configuration are automatically and transparently integrated with Openshift and Kubernetes through config maps with no change in the code. Config maps are a concept within the Kubernetes world. If you've never heard of them, don't worry. It's essentially a way to package up the configuration of an application and make it available to it outside of the application itself. So if you want to change the configuration, no recompilation and redeployment is necessary. You simply drop in a new Spring Boot starter in your build config, and when it's deployed to Openshift, the apps will then be able to pick up their configuration from those config maps deployed in Kubernetes and Openshift. In addition, Rohr features support for using the Red Hat stack within a Spring Boot application. For example, you can embed Tomcat, or you can do messaging through ActiveMQ as alternate choices to the Spring Cloud stack, with, again, more integrations on the roadmap for additional pieces of middleware that Red Hat champions today. Red Hat is really all about open choice. So as a Spring developer, you're not forced down any one path. You can continue to use the frameworks and tools from the Spring ecosystem that you've used for your Spring apps, and you can gain additional benefits through the integration with Openshift and Kubernetes through Rohr. Okay, last but certainly not least is Node.js. So Node.js is a huge community, and it actually has the largest package registry in the world with over 400,000 different packages. One of its biggest advantages of the runtime is that pretty much everyone knows JavaScript these days. As I mentioned earlier, it has a very long history with the first browsers on the web. So Node.js uses the Chrome V8 JavaScript engine, and very similar to Vertex, enables developers to, again, build event-driven, non-blocking apps that can scale, although the execution model of Node.js is somewhat different from Vertex, as there's no concept of what I mentioned earlier of vertical, which is specific to Vertex. That doesn't exist in Node.js, so you can't assign a vertical to an individual CPU core. So if you want to take advantage of a multi-core system, multiple Node.js runtimes would need to be invoked if you want to run across those multiple cores, which may or may not be an issue depending on how you architect your individual microservices. Both Node.js and Vertex provide really good performance, especially for high-scale web apps, and Node's ecosystem is clearly a winner here. Pretty much those 400,000 packages guarantees you'll be able to find the functions you need. Of course, if you can't find it, you can always write it yourself and contribute it back to the community. So in the first release of Rohr, Node.js is offered as what we call a developer preview, which means limited support or no support initially. We expect to add full support for this runtime in a future release, but for the moment we're building the components we need to integrate Node.js apps with the wider Red Hat ecosystem. So like Spring Boot, Node.js and Rohr features those integrations with Openshift and Kubernetes for Node apps, including externalized configuration, health checks, and a number of others that make sense in a microservices architecture. Okay, so as I mentioned, Rohr is available today, so you can go and use it today. You can use the runtimes that are supported within the Rohr offering. But as we've seen, and I've kind of alluded to, and as you probably all are aware of, software is constantly evolving, and that's really true at Red Hat as well. So I want to spend the last few minutes to take a look at what's coming up in the very near future in the context of application development and cloud native. So really what we've witnessed in the last 3 to 4 years is kind of that renaissance in app development, that Cambrian explosion of frameworks and technologies, the moving from traditional 3-tier on-prem stateful apps to distributed microservices running on the cloud. All of this awesome technology today comes at a cost to the developer, who now has to take this nature of distributed services, stateless cloud apps, and app resiliency into account when developing apps. So what we're in the middle of now is a sort of a 2.0 version of that renaissance, which aims to further reduce that complexity that we brought on ourselves and our developers. So what we're seeing is that, much like the sedimentation of middleware services into the infrastructure layers, the networking, routing, tracing, discovery, and resiliency requirements for modern apps are now starting to also sediment down into the infrastructure. So as we move forward into the future, the burden of developing these distributed fault-tolerant microservice apps becomes much less, and the developer can continue to concentrate more on really what matters most, which is the business logic and the features that bring true value to the business, and let the infrastructure deal with the hard problems. So earlier this year, Google, IBM, and Lyft announced the Istio project, which aims to make it easier to develop, connect, and manage these complex and distributed microservice applications. So the first generation, or 1.0 microservices, were mainly a DIY effort. You had to kind of do a lot of defensive programming in the app itself. Istio basically delivers on this microservices 2.0 idea of minimizing the requirements on the developer for dealing with these distributed nature of these apps. So in this diagram's from Christian Posta, a chief architect for cloud application development at Red Hat. You can see how this roughly translates to apps and what it means. Essentially, it pushes that real magic behind distributed apps like routing, rate limiting, or circuit breaking into the lower network layers, out of reach, and more importantly, out of control of the application developer. It also means that this so-called service mesh benefits all applications running on it, regardless of programming language and communication protocol. So think that like databases or maybe IoT applications with binary streaming. In the past, in order to get some of these features, you had to have a specific language binding of that feature to the language that you've chosen. With Istio and the service mesh, that's no longer true, because all of this operates well below the application layer. So to give you a quick example of what this looks like, here's a rough diagram of the components at play. Istio kind of creates this cross-cutting platform level, what I alluded to earlier, a service mesh to address these common microservice architecture concerns, and there are a ton of them. So communication, load balancing, traffic routing, metrics, quotas, authentication, rate limiting, circuit breakers, timeouts, automatic retries. You can guess I didn't memorize that list, but the list goes on and on. So the things that developers and operations currently have to deal with today. It does this by injecting what we call sidecars or sidecar proxies for each of the services, each of the microservices deployed to a cluster. That proxy acts sort of as a front end to the service itself and is able to manage traffic according to policy. So as services come and go, then their presence or absence are tracked by this control plane, and the traffic to the application is shaped accordingly. So Red Hat customers and the greater OpenShift and Kubernetes communities will definitely are benefiting from this platform level support today. So stay tuned as we work to bring a developer preview of this technology to customers by Red Hat Summit in May, and then later on in the year fully integrate it into OpenShift and the Rohr Getting Started experience. So very exciting stuff in this space. Another evolving space at Red Hat and beyond is the concept of serverless architectures. You've probably heard of this already. Sometimes it's called function as a service. Serverless is a major shift in the way developers build and deliver software. And much like Istio and the service mesh, serverless removes even more infrastructure complexity from the applications and from the application developers themselves. So in the serverless model, developers still think about apps as a collection of services, but now those services sort of run on an opaque execution platform, completely managed for and insulated from the developer. So very similar to the Istio, kind of takes some of that responsibility away. Serverless does the same thing. So this is in comparison to the typical microservice 1.0 applications running on a container platform, where the mechanisms of executing those containers are fully exposed to the developer, who needs to do a lot of sort of bookended boilerplate logic to handle the startup, execution, and shutdown of that service. So one question we get a lot is, will serverless kill containers? So the answer is a bit nuanced. So today, OpenShift exposes containers to developers on the platform, as I mentioned, but developers aren't required to be intimately familiar with how those containers are spun up and managed on the platform. And it's also true that as a serverless developer, you don't need to deal with containers. You sort of just write service code and it gets executed by something somewhere. But containers are still the best way to manage that execution for serverless apps. So this concept of executing code in containers doesn't really go away. It's just one less thing developers have to deal with if they choose. So the obvious benefits here are economy of scale for extremely high utility computing, where you're essentially billed for exactly what you use with very little to no waste. But as I mentioned, serverless also reduces the developer burden to deal with these infrastructure concerns of running applications, essentially just running them somewhere. So another question you may have, if serverless is part of the microservices 2.0 revolution and I'm looking to modernize, should I just skip right over microservices and go straight on to serverless? Again, the answer is a bit nuanced. First of all, if you're not doing microservices yet, you probably have some homework to do before you can even make a choice between serverless and microservices. Answering questions like, is your organization doing DevOps? Are you happy with the speed that you can deliver apps? Are you happy with using things like fast-moving monoliths? Is that enough for you? Are your developers able to sit down on day one and spin up a complete self-service dev environment and get started, or do they have to wait 2 to 3 weeks for IT to provision a new environment for them? Are you able to do advanced deployment scenarios like blue-green deployments or canary deployments? If not, you're really not ready for serverless or microservices, so you're not in a position to make that choice yet. At the end of the day, it's really about control versus efficiency. If you need full control of your execution environment, including how and where the apps are deployed, containerized microservices might be the way to go for you. If you're willing as a developer to give up some of that control and gain a lot of efficiency in exchange, and you like the speed of development that serverless brings, then serverless might be a better fit for you. Again, use the right tools for the right task. If you're writing serverless code, then you also may be asking yourself, does it matter which serverless platform you use? After all, the actual code that you're writing are simply code fragments written in things like Java and JavaScript or Go or Python or some other language that essentially can execute equally well on any architect or any platform, whether it's Amazon Lambda or Azure Functions or some other serverless platform. So code portability, the raw code portability isn't really the issue. What is the issue is the developer toolchain and the mechanisms for wiring event sources and triggers and actions together. If what you're doing with your serverless code is tying into existing AWS services like Kinesis or Aurora using Lambda, then you're sort of locked into that ecosystem already and the choice has been made. Right now, the use cases for serverless are mainly centered around what we call cloud ops, which is kind of sort of a simplified way to explain it is replacing utility scripts for things like image manipulation or email processing with a function as a service, which are kind of peripheral to the applications that they're designed for as a whole, and they're attached to specific cloud providers. But in the very near future, we're going to start to see entire business applications being built with serverless architectures, which we haven't really seen take off yet. And that's where your choice of platform will become even more mission critical. So earlier this year, Red Hat did a lot of research in this space, and we came to the conclusion that Apache OpenWhisk met our needs of our customers and developers the best. We thought it had the most advanced feature set, the most mature code base, and had the largest ecosystem of collaborators, which are all very important to developers and Red Hat customers. So our immediate plans in the serverless space is to help finish up the Kubernetes integration work and get Apache OpenWhisk running on Openshift as a developer preview again by May, which is the Red Hat Summit. Beyond that, we're looking at how best to integrate serverless within the larger ecosystem, larger Red Hat ecosystem product lines around middleware and OpenShift.io, which is our online developer tools. So stay tuned for more information on that coming up in the next few months. Okay, so I've talked a lot about what we're seeing in the industry, how this relates to cloud native and how this relates to the technologies that we're introducing with Rohr. So what can you do next? What can you do today with the offerings we have? So the first thing you want to do, if you're a developer, is you go to learn.openshift.com. So on learn.openshift.com, we've set up a number of self-paced, hands-on guided scenarios that don't require installation of any software. It runs completely in your browser, so no downloading of packages or unzipping anything. You'll find the scenarios for the runtimes I discussed today there. It'll spin up an OpenShift cluster for you. It has a sample application that you walk through and develop some additional features on using the different runtimes. It's a great way to learn more about Rohr and about how OpenShift and cloud-native applications work in a cloud-native application world. Next, you'll want to check out the site I mentioned earlier at developers.redhat.com/launch. So on this site, again, we feature a number of sample microservice apps that showcase various features of the Rohr runtimes. You can clone these projects and deploy them to OpenShift Online or to your own IT infrastructure to see if it is a good fit for your existing infrastructure. You'll walk away with a completely self-contained application that is deployed to OpenShift. And you can kind of explore that on your own after you've completed the initial setup and deployment of the booster itself. Okay, and lastly, we have a number of authors, both from Red Hat as well as from other open source communities, writing some really great material on microservices. You see the book here on the left from Christian Posta, someone I mentioned earlier. There's a number of others that are shown here. If you want to learn more and get these free ebooks, you can download them at the bit.ly link you see at the bottom of the slide there, bit.ly/rohr-reading. And you can get information on the Red Hat Developer Program as well for developers who want to learn more about Rohr or OpenShift or modern microservice applications or cloud-native applications. Okay, so I think that's the last slide. So I hope you learned a bit more about what Red Hat's doing here for app developers and this bright cloud-native polyglot poly-architecture future that we're super excited about. I hope you're as excited as I am to see where we're going. I know I am. So hopefully you've learned a bit today. And thanks. That's all I have today. So I'm going to hand it back to Dave for the Q&A session. So Dave.
Very nice presentation, James. Appreciate it.
Thank you, sir.
A couple of things jumped out. First, I want to remind all of our attendees that now is a good time as any to ask a question. and to do that by going into the control panel, typing in the questions, and submitting it. So let's get started right away. And one of the first questions is, I know it's a kind of nuance, so maybe you might want to elaborate on the difference between cloud native and microservices.
Oh, great. That's a great question. So they are different. So cloud native is a term that describes applications that are built to take advantage of the benefits and the limitations of a cloud environment. So for example, changing network conditions or configuration, responding to dynamic workloads, moving app components around a cluster, building them through a pipeline, things of that nature. So it's essentially just a collection of characteristics of an application that make it better run on a cloud infrastructure. Microservices, on the other hand, is a specific terminology describing an application that is a cloud-native application, but its primary goal is speed to market, or speed or time to market, and also to kind of limit the collateral damage when things go wrong and unexpected bugs and spikes in demand occur. So individual microservices are also split along business boundaries rather than functional boundaries, and they're independently deployable. So you can have multiple teams working on individual microservices at any one point in time. They can deploy them and redeploy them and update them, and things don't break if they're deployed, if they're architected as a microservice application. They're also polyglot, so they can be written in any different language. So cloud native is a set of characteristics of an app. Microservice is a specific kind of app that is cloud native, but has a primary goal of speed to market.
Mm-hmm. All right, very good. So another question that came in. So what kinds of applications aren't well suited for serverless?
Yeah, so that's a good question. Sometimes we make serverless out to be kind of the obvious and next step after microservices, and that eventually everyone's going to be there. But whoever asked it, you're absolutely right. There are application types that don't really make sense in a serverless environment, mainly those that are sort of long-running processes. The nature of serverless is that it's ephemeral and short-lived, and the things that are actually executing the code can be environments. So for example, for a JavaScript environment, microservice, you might want to, as a provider of a serverless platform, spin up a Nodejs runtime, execute code, and then shut it down. You don't leave it up and running eternally. So an application that's assuming that non-ephemeral state is true, like they can run forever, those are the types of applications that really aren't amenable to a serverless architecture. So specifically, things like BPM processes where there's human interaction involved. Those can take, the typical example is a loan processing BPM set of rules, and that usually requires human input. And if it's run on a Friday night, you might not get any human input until Monday morning. So the serverless environment is going to shut that down, and you're going to lose that state. So those applications which assume long-running state are generally not as good in a serverless environment. In addition, things that take a long time. So serverless environments, they're typically expected to serve the results very quickly and to get that kind of utility computing. So things like, things that take a lot of CPU and a lot of time to run, image processing, big data jobs, those kinds of things aren't necessarily good for a serverless environment.
Mm-hmm. Excellent. All right, the next question is kind of a two-part question. So the first part is, how do I know exactly what is supported in each Rohr runtime? And the second part of the question is, will Red Hat be providing a support contract? For example, can somebody put in a support ticket on a WildFly Swarm app or on a Spring Boot app?
Great question. So to answer the first part, how do you know exactly what is supported? So we have documentation on docs.redhat.com. There's actually, if you go to docs.redhat.com, there's a link for the Red Hat Openshift application runtimes. And then within there, each of the runtimes, it's spelled out in excruciating detail exactly what is and what is not supported. Each of the runtimes are, well, I should say there's multiple ways to deliver runtimes. And in our case, for Java-centric runtimes like WildFly Swarm and Spring Boot and WildFly Swarm, those are represented as what we call Maven artifacts. These are essentially jar files that are wrapped in some metadata made available through a Maven repository, and you'll find a list of all of the different Maven artifacts for the different runtimes listed in that documentation, and it explicitly says what is and what is not supported. Primarily what is supported are those things targeting microservice applications, so things like fault tolerance and health checks and external configuration libraries. The components within the runtimes that implement those are fully supported. Having said that, we also have components in Rohr that we call tested and verified. So these are where we don't provide sort of SLAs, where we guarantee a bug fix or a patch. Those are frameworks like Spring Boot is one of them. Some of the Netflix components as well. We aren't we're unable to deliver patches for that. We don't want to fork the upstream communities. So we essentially provide tested and verified solutions for those runtimes. For the runtimes where we are able to offer patching, like WildFly Swarm and others, those are fully supported. Some of the components within the Spring ecosystem are fully supported, things like our embedded Tomcat solution and a couple of others, and those are listed in the documentation. So it's a bit of a nuanced question. I know it would be easy to just say 100% everything supported, but in reality, being based on open source means that we need to make some decisions about what we can and cannot support. I think that got actually both of the sets of questions.
You did, and actually you jumped in and got the third question when somebody was going to ask what is the difference between supported and tested and verified, but you jumped right in there and got that one too. So
yep. So supported
well done.
is the definition that everyone knows and loves of supported. Tested and verified means we run them, we regularly QA them, but we do not offer patches to those individual runtimes. As time goes on and the upstream runtimes themselves evolve, those new versions will be included in future releases of Rohr as well. So you will get those fixes, just not through the Red Hat support model for things like Spring Boot and Netflix.
Very good. All right, so it seems like we've run through all of the questions that we had today. So let me just throw it back to you, James, for perhaps a 60-second takeaway. So anybody attending the webinar, what would be the critical takeaway for them to understand?
Sure. So I guess the takeaway is that, to simplify things greatly, everything is evolving in the app dev space. So we're seeing microservices are hot today. We see serverless and the concept of a service mesh coming to be more popular as time goes on. I guess the main takeaway is that with Rohr and with Red Hat, not only can you depend on the open source roots of the company, you can also depend on us supporting both traditional existing applications as well as modern cloud native applications. So this presentation is primarily focused on cloud native, but we have a ton of customers, and I'm sure there are many of your readers and listeners out there that are thinking to themselves, this all sounds great, but my IT department's never going to go for containers because we just don't trust them. So there are a number of solutions from Red Hat with Rohr and with things like Red Hat Ansible and Red Hat Openshift that make it possible to support customers who want to move fast and for the customers who want to move slow. So we kind of are that kind of, we want to be that trusted partner where we can help you understand your existing application infrastructure and your existing application sets, as well as give you some guidance as to how best to move forward with your applications and really kind of help you through that I hate to say the cliched digital transformation process, but that's exactly what it is. So I think that's the main takeaway. Okay, so I think I'm done, Dave. So I will pass it back to you to close us up.
Great. Thanks, James. Appreciate it. I want to thank you for the great presentation. and thank Red Hat for sponsoring this fine event, and thank everybody who hung in there for just about an hour to listen to all this great information. So once again, I'm Dave Rubenstein, Editor-in-Chief of SD Times. So long for now, everybody.